Hello, everyone, and welcome. Today, we are going to look at the nuclear fuel cycle. You can think of it as a journey, one that starts with a simple rock and transforms it into a very powerful source of energy. And we will see how at each step we add value, and of course, how this relates to the cost. So, let us begin.
To understand this, it is good to think about oil. You see, you cannot put crude oil from the ground directly into a car. It must be refined to become gasoline. Well, uranium is exactly the same. The raw uranium ore that we take from the mine must go through many sophisticated stages to become fuel for a reactor. Each of these stages adds value, and each one is a part of the total cost of the fuel.
So here is our plan for today. First, we will start at the very beginning of the journey. Then we will look at what we call the front end. This is all the work we do to prepare the fuel. After that, we discuss the back end, which is very interesting because it is where we find more value. And finally, we will see how everything comes together in what we call the French closed cycle solution. Okay, so let's start at the beginning. The whole idea of nuclear energy is actually quite simple. It's about releasing the very, very large amount of heat that is stored inside uranium atoms. The process to do this is called fission, and it is this heat that we use to generate electricity. So what is fission? It's the action of splitting the center of an atom, the nucleus. And when we do this, it releases a huge amount of energy as heat. In a nuclear power plant, our entire job is to create this reaction and, of course, to control it safely. Now let's look at the front end of this cycle. This part includes every step we must take to prepare the uranium before it can go into the reactor. These are the very first and most essential stages where we begin to build the fuel's value.
The front end has four main stages. First is extraction, then conversion, then enrichment, and the last one is fuel production. We will now look at each one.
The journey, it starts in the mine. We extract uranium ore from many different places in the world, from Canada to Africa to Australia. You know, this diversity is very important for you, our customers, because it guarantees a secure and stable supply. After we mine the ore, we crush it and process it into a concentrate, a powder we call yellow cake.
The next step is called conversion. The yellow cake is a solid, but for the next part of the process, this is not useful. So we must do a chemical transformation. We turn this solid powder into a gas, uranium hexafluoride, or UF6. This is a very important preparation for the next stage.
And this brings us to a major challenge. You see, in natural uranium, only a very, very small part can produce energy. This is the uranium-235, and it is only 0.7%. For most of today's reactors, this is just not enough to work efficiently. So our goal is to increase this percentage. We take the natural uranium, which is at 0.7%, and we increase the concentration up to about 3 or 4%. This step is where we add enormous value to the fuel. It is also, of course, a significant part of the cost.
And we call this process enrichment. It is a very high technology process. We use centrifuges, spinning very fast, to separate the useful U-235 atoms from the others. It is very precise, it uses a lot of energy, but it is absolutely necessary to create a powerful and efficient fuel.
And now, the final step of the front end, fuel production. We take the enriched gas, the UF6, and we turn it back into a solid black powder. This powder is then pressed into these small ceramic pellets. You can see they are very durable. We stack these pellets into long metal tubes, and then we bundle the tubes together, and this is the final product, a fuel assembly, ready to be delivered to your power plant.
But the journey is not over. After maybe 3 or 4 years inside a reactor, we take out the fuel assembly. Many people see this as the end. They call it waste. But for us, this is the beginning of the back end of the cycle. This is where we unlock even more value by recovering materials we can use again.
The back end also has 4 key stages. First, we have treatment for the used fuel. Then, recycling of the valuable materials. Then, conditioning for the final waste. And at the end, long-term storage.
Now, this number is very important, 96%. 96% of the material in a used fuel assembly can be recycled. This means only 4% is final waste. So you see, this changes everything. This is not about waste management, it is about resource management. Inside this recycled material, we find not only uranium, but also plutonium, which is created in the reactor, and the energy here is immense. Just 1 gram of this plutonium can create the same energy as 1 ton of oil. This gives us a very powerful reason to recycle, for the economy and for the environment.
So what about that small amount that is left, that final 4%? These are called fission products. To manage them, we mix them with hot molten glass. This process is called vitrification, and it creates a very stable, very solid block of glass that makes the final waste safe and simple to handle for storage. And to give you an idea of the volume, it is incredibly small. In France, for 1 person for 1 year, the final high-level waste is less than 5 grams. That is about the weight of a small coin, like a 20-euro-cent coin. This shows the environmental footprint is really, really minimal. So, when we combine the front end, the preparation, and the back end, the recycling, what we get is the complete French closed cycle. This is our vision for a fully integrated and sustainable approach to nuclear fuel. For you, the customer, the benefits of this closed cycle are very clear. First, you maximize the energy you get from your uranium. Second, you minimize the final waste to a very small, very safe amount. And third, you create a more sustainable and secure energy supply for the future of your country.
This complete vision of the fuel cycle, where we value every part of the material and waste almost nothing, it offers a very powerful model for the energy sector. And this brings us to a final important question we should all think about. Is this the future of sustainable energy? Thank you for your attention.